Okay, so today in today in class we talked about proofs in section 4.3. We started with what we called baby proofs, so we'll go through one of those, and then we looked at a worksheet that had maybe one more step to it. So let's take a look at one example of each to get you started. Excuse me. All right, in this example, we were given several different bits of information. We are given that angle A is congruent to angle D. So I'm always going to mark it and see what I can find. I'm given that AF is congruent to DC, and I'm given that angle BFA is congruent to angle ECD. So we know that when we're trying to prove something, we need to prove triangle proofs using one of our 5 theorems. Angle, side, 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 angle, side, angle, side, or hypotenuse, leg, which again, you have to have a right triangle for that one. When I look at the given information that I have right here, I can see that in each one of these triangles, I have corresponding angle, side, angles. Angle, side, angle. So they both have those congruent pieces. So this is what we call a baby proof because all of the information we need to say that these two triangles are congruent is already given. So here I'm going to write my statement. Angle A is congruent to angle D. AF is congruent to DC. And angle BFA is congruent to angle ECD. All of these are because they are given. Since I already have all 3 pieces that I need, my step 2 can be my proof statement. AFB is congruent to triangle DCE, and the reason being angle, side, angle. So there's baby proof. The second one that we did in class looks very similar, but just you're kind of given different information. But again, it's another one of those baby proofs. In this second sheet, we looked at ones that are maybe you have to do one extra step. Maybe 2 of the things that you need are going to be given, and you're going to have to find one more. So let's take a look at this situation. We've got GDF, which is this angle right here, is congruent to EFD, which is this angle right here. We are being given that GFD, this one, is congruent to EDF, this one right here. So as we can see, we've got 2 angles that are corresponding and congruent, and we need one other piece of information. So I know I have 2 angles, so side, side, side is out. HL is out because I don't have any right angles. I'm thinking maybe angle, angle, side, maybe angle, side, angle. Right? Those are probably, and side, angle, side is probably not going to work either. So I'm down to these 2. Oh, I'm sorry, I wrote angle, angle. Angle, angle, side, and angle. Sorry, that's supposed to be angle, side, angle. Okay, so it's going to be one of these 2. All right. The only other piece of information that I can definitely say from this given information is that they both share this segment DF. In this triangle over here, right? It's this longer segment over here. The other triangle also shares that segment on this side. So we can also use this DF congruent to FD. And that will give us angle, side, angle. So let's write out our proof. Angle GDF is congruent to angle EFD, and angle GFD is congruent to angle EDF. These guys are both given. The other thing that we need to mention, I've got an angle, I still need to mention this side in order to get angle, side, angle, is that DF is congruent to FD. The only reason I switched the order is because one time the triangle is going this way, and then the other time it's going this way. It's not a huge deal, but we want to be picky. The theorem that we know for this is if you're looking at something, if it's congruent to itself, we call that the reflexive property. So I now have enough information for my proof statement. Just because of time, I'm just going to kind of do one of these guys. And over here, we're going to say the reason is angle, side, angle. Okay, this one, that's the second one, is very similar to the first one. But you're going to end up having a reflexive angle B because they both share angle B. So you can try that one on your own and let me know if you need me to post the answer to it. But I want to show you one more. This one, it says AX is the perpendicular bisector of BC. So this one, a lot of it isn't explicitly written out for us. We have to kind of come up with some of this on our own. Well, if AX, this segment right here, is the perpendicular bisector of this segment, that means I know two things. I know that it's perpendicular, so these guys are right angles. So those are congruent angles. And I also know that it's a bisector. So this segment, BC, was cut in half by X. That also gives me two segments that are congruent. So right now, I have an angle and a side. And I need either an angle, angle, side, angle, or maybe I need another side or something. The other one that's easy to find is, again, this reflexive property. This AX is shared by both of those triangles. So what we're going to do for this one is we're going to write our given statement. AX is the perpendicular bisector of BC. That was given. Because of that, I knew two things. I knew that BX is congruent to CX, and I also knew that I had these two congruent right angles. So I'm going to say also that angle AXB is congruent to angle AXC. The reason I know that is because that's what a perpendicular bisector does. So I can say definition of perpendicular bisector for these two items. So here I got a side, here I got an angle, and now I just need to mention this last side, and then I'll have side, angle, side. So the last part that we have to prove is that AX is congruent to AX. This is because of the reflexive property again. And once I have side, angle, and I just proved the last side, I can now say that triangle ABX is congruent to triangle ACX, and that reason is because of side, angle, side. There's one more on the paper that I want you to try, and let me know if you need me to post the answer to it.